Hi everyone, we're continuing with 3.4 and 3.5, and we're going to start solving exponential equations, which contain exponential expressions like this over here. An exponential expression has a constant base, the 3 here, for example, and a variable exponent, like the x plus 1, containing x, t, or whatever. Okay, so let's now solve the equation 2 to the x minus 10 equals 0. This contains the exponential 2 to the x, the basic exponential. Okay, for something like this, it's easy to isolate this exponential 2 to the x. And we can accomplish that by adding 10 to both sides of this equation. Please say adding 10, not moving 10. If you say move 10, then you're in danger of messing up your sign. So we're going to add 10 to both sides of this equation. And we get 2 to the x all alone equals 10. Okay, we can solve this in a couple of ways. First, I'll show you the mathematician's approach. Now, we have here an exponential, 2 to the x. We want x alone. Well, what undoes an exponential function? Its corresponding log function. So let's take log base 2 of both sides. Method 1, we're going to basically insert logs. Log base 2, both sides. So we have log base 2 of 2 to the x, it's good to have this in parentheses, equals log base 2 of 10. Now, look at this. On the left, we have log base 2 of 2 to the x. By the inverse properties, some people think of this as a canceling. I don't like that so much because it's not like multiplication, but these basically undo each other. And for all practical purposes, you end up with x on the left-hand side. X equals log base 2 of 10. And in fact, that is the exact solution. Now, if you want to approximate this, you can use the change of base formula. Log base 2 of 10 is ln of 10 over ln of 2. You can calculate this using your calculator, and you get approximately 3.3219 to 4 decimal places. Okay, technically it's a solution set. I'll show that in a moment. First, I want to show the second method of doing this. Again, we start off with 2 to the x equals 10, all right? But since we know that we're going to deal with natural log on our calculators anyway, or common log if you wish, let's go ahead and take natural log, let's say, of both sides. So let's take the natural log of both sides, and we get ln of, I'll move this up a bit, ln of 2 to the x equals ln of 10. Okay, now this time it's not the inverse properties, but look what we can do on the left-hand side. We can take the x and smack it down by the power rule. And we get x times ln of 2, which is just a number, it's just a constant, equals ln of 10. In fact, on the left side, it kind of acts like 3 of x or 4 of x. It's just that ln of 2 is a weirder coefficient. Well, we have x times a number equals ln of 10. How do we solve for x alone? We divide by ln of 2 on both sides. X equals ln of 10 over ln of 2. That should look familiar. That's the same expression we got over here. And of course, it rounds off to the same number, 3.3219. And technically, we write that in solution set form. Remember that when you solve an equation, your answer is technically a solution set. It could be the empty set, or all real numbers. All right. Now, let's take a look at a slightly more interesting exponential equation. 5 to the 3x minus 1 equals 125. Now, before you jump into it and take logs of both sides, this is actually a bit more interesting because 125 is itself a very nice power of 5. It's 5 to the what? It's 5 to the third. Okay, and look what we have here. 5 to the 3x minus 1 equals 5 to the third. By the one-to-one properties, we can equate these exponents. We have powers of the same base on both sides. We can equate the exponents, and we get a simple linear equation. 3x minus 1 equals 3. Add 1 to both sides, divide by 3, and we get x equals 4/3. And that's our solution set, the set consisting of 4/3. Bear in mind, you might get more than one solution or no solution. Here we get one solution, once again. Now, bear in mind, if back here, if you had taken the log of both sides, if you had taken ln of both sides, if you had taken the natural log of both sides, then you would have gotten an uglier expression. It would have been equal to the 4/3, but the thing is, your instructor has the right to mark you down if your answer is not simplified to the nicest form. And of course, 4/3 is a lot nicer than an uglier ln expression that you would have gotten if you had tried the ln method. Earlier, I was going to say log base 5. Now, if you take log base 5 of both sides, then you pretty much get this linear equation once again. So if you take log base 5 of both sides, you will end up with 4/3 as a nice form. But if you take natural log of both sides, or some other log, then you get an uglier expression, which may technically give you a correct solution, but not in simplest form. And your instructor has the right to demand something like 4/3 if the answer is basically 4/3. Okay, so we've solved a couple of exponential equations. Now we're going to apply these ideas to solving sort of real-world problems, exponential models. Okay, I'll see you next time.